Welcome back. For these next equations, we're still going to be dealing with fractions, but we're going to have expressions in the denominator. And so we have to be a little bit more detailed in our process. First thing we have to check is the domain of the variable. As soon as you have variables in the denominator, we have to worry about when that denominator is equal to 0. And then the rest of the process is pretty similar to the example that we just did, except we have to find the solutions that are in the domain. Okay, so let's see how that works. First of all, I'm going to begin by factoring each denominator. And once it's in factored form, I can see that the least common multiple of all three denominators is x minus 2 times x minus 1. And I also know that the excluded values are that x can't be 1 and x can't be 2. So the domain is everything else. It's minus infinity to 1, union from 1 to 2, and then from 2 to infinity. So when I am looking for my solutions, I have to pay attention to this and make sure that my solutions are in that domain. Okay, so that's the first step. Once we have that done, then we just go through a very similar process to the last example, only we're doing it with variables. We multiply each term by that least common multiple. Okay, so we'll take x minus 2, x minus 1 times the left-hand side of the equation, and then to maintain equivalence, I have to multiply that by the right-hand side of the equation. Okay, so what happens when we do that? We can see that we're going to get a cancellation here. So we'll have 3 times x minus 1 equals, now when I multiply that, I have to multiply through each term by that least common multiple. And what that does for us, as you can see, is that it does enable us to clear fractions, because I'll have a cancellation of factors in the first term and a cancellation of both factors in the second. Okay? Now notice though what I've done. This equation has as its domain all real numbers. So when we solve this, that's how we're going to solve it, but we're going to have to look for any excluded values, because we may have added solutions that are not solutions to the original equation. Does that make sense? So it's okay to do these steps, we just have to check at the end. Okay, so now we solve. 3x minus 3 equals x minus 2 plus 7. So 3x minus 3 equals x plus 5. And then we isolate our variable. Let's combine the x's. And we get 3 plus 5. So it looks like 2x equals 8, or x equals 4. Okay? And when I look at that, I see that we have one solution. Let's look at the excluded values. It's not 1, it's not 2, so it works. Is a solution. And again, if you want to check in the original, I just go back to my original equation and plug in 4 wherever I see an x. And the question is that equal to 1 over 4 minus 1 plus 7 over 4 squared minus 3 times 4 plus 2. And check that out. 3 over 2, is that equal to 1/3 plus 7 over, let's see, 16 minus 12 is 4 plus 2 over 6. So the question is 3/2 equal to, let's see, that'll be 2. 2 6 plus 7 6. Okay, well that's just 9 6. And if you reduce that second fraction, it does work. Sorry about that. Now you can look at that or check and see that it is a solution. So the answer to this problem is x equals 4. Okay, let's do one more example. Right, same process. And here again, in order to see what I'm going to be working with in terms of excluded values and the least common multiple of the denominators, I'm going to factor. And the least common denominator of all of those is the product. And our excluded values. X can't be 2, and x can't be -2. Okay, so now I multiply through by that least common multiple or least common denominator. So it'll be x minus 2 times x plus 2 times 2x over x squared minus 4. And then it's going to be x minus 2 times x plus 2, again times that whole expression, okay, all right, and when we do that, of course, what happens is we are able to clear the fractions. So the left-hand side just becomes 2x, and I have x minus 2, x plus 2, and don't forget, each term has to be multiplied through by the LCD, and cancellation, and we do have a cancellation, and I'm left with 3 times x minus 2. Okay, again, I've cleared of fractions, but I may have also introduced an extraneous solution. So let's check that out. Let's solve it. So 2x equals 4 minus 3x plus 6. Be careful of the algebra there. Combine like terms, bring that over. I get 2x plus 3x equals 4 plus 6. 5x equals 10, and so I get the solution x equals 2. But I have to check, oops, it's an excluded value. So this one will not work. X equals 2 is an excluded value, so this equation has no solution, or the empty set. Okay? Because the only possible solution has already been excluded. And notice that we have a terminology for this. We've been using it already. A solution that we find that does not match the original is what we call an extraneous solution. And we're going to see several situations, several scenarios where that happens in these examples. Okay, one last example of clearing of fractions is if your denominators are single factors and there's only one term on each side, then we can use cross multiplying. And the reason we can do that is that here the LCD is just the product of those two denominators. Notice our excluded values are x equals 2 and x equals 1. So when I multiply both sides by that LCD, what happens? We have a nice cancellation, and we end up with the equation 3 times x minus 1 equals 1 times x minus 2, which is exactly what we get by cross multiplying. So in this scenario, cross multiplying is perfectly fine. Just remember those excluded values. Okay, now if I quickly solve this, I get 3x minus 3 equals x minus 2, and bring that over. 2x equals 3 minus 2 is 1, so x equals 1/2, and I'm going to let you check that and make sure that that works. Okay, thank you.